Last chapter we talked about objects that were being thrown into the air. Now a lot of times we talked about, a ball that's being tossed up into the air, goes straight up, ball comes straight back down. We also talked about objects, for example, an apple that's hanging from a tree, and of course it goes ahead and falls when knocked free. We also talked about, airplanes that were taking off. We talked about uniform acceleration and things like that, but really all we were talking about was motion in one dimension. Well, what we're going to be looking at this chapter is we're going to be talking about motion in two dimensions. We're going to first start talking about horizontal motion and then adding vertical in once it leaves a horizontal plane. And then what we're going to do is we're going to also then talk about objects that are launched at an angle. For example, a golf ball being teed off. You know that ball is hit forward, but it is also hit up into the air. For example, we can also talk about, let's just say, a football being kicked off from at the start of a game. And again, when you think of that ball, it is going horizontally, but it is also rising into the air. So some terminology that we need to go ahead and take care of first. A projectile is just going to be any object that is launched into the air. Again, we could talk about a golf ball, basketball, volleyball, anything that's going to be launched into the air. Rocks, for example. Now, what specifically we are going to be focusing on in this chapter is we're going to be looking at the trajectory of it. And what that's going to be is the path that projectile is going to follow while in the air. If you go ahead and look at this water, again, you've got the water here, launched out, reaches its highest point where gravity causes it to stop, and then all of a sudden the water begins to fall. Well, what we're going to do is we're going to launch a ball horizontally. So I'm going to have this apparatus sitting on my desk. And what it's going to do is spring-loaded, and what it's going to do is it's going to shoot a ball horizontally. At the same time it shoots that ball horizontally, another ball is just going to drop vertically. And what I want you doing is I want you coming up with an idea of which projectile is going to hit the desk first. Now again, I want you to have this idea in your mind. One thing I will tell you is I'll give you a little hint. If they make two distinct thuds, okay? If they make two distinct thuds, every single one of you are going to get an A for the semester. No test, no homework, any of that. But if you have them make one distinct thud right away, well, then you're going to have to work for your A. The reason why they hit the table at the same time was because of gravity. Again, both of them were being suspended here in the air. When I released the spring and it shot the one horizontally and dropped the one vertically, again, what's the only force that is acting on them? And hopefully you're going to say gravity. Because again, once it's released from the platform, gravity takes over. Gravity was affecting them both at 9.81 meters per second squared downward, and that is the reason why they hit the desk at the same time. Now, really what we're going to be looking at in this section right here is we're going to be focusing on horizontal movement initially only. Okay. Oops, sorry, trying to write with my mouse and not quite the best thing here, but okay. What we're doing is we're going to say that a ball is rolling across a table. And as it rolls across that table, think about it. It's rolling across the table. There is no vertical motion to it. And if there's no vertical motion, again, that initial vertical velocity is going to end up being 0. If we go ahead and look at this sample problem, it says a ball is rolling across a table that is 0.75 meters high. Okay, so let's go ahead and let's draw our table here. So here's our ball moving across the table at 4 meters per second. Now basically when that ball gets right here, okay, Basically, it's going to leave the table, gravity is going to take over, and basically the path of this ball is going to continue forward, but it's going to fall. So what we're saying is it's going to land a certain distance out here away from the table. And again, that's what that first question's asking. It says, what horizontal displacement will the ball have from the table? And then finally, it says, well, what vertical velocity will that ball strike the floor? Some equations that we're going to end up using. Okay, to find the horizontal movement of this, we're going to say that the horizontal displacement is going to be equal to the initial horizontal speed multiplied by the time. The other thing that I want to point out here is the final horizontal velocity is going to be equal to the initial horizontal velocity. It's going to continue to travel forward at 4 meters per second while it is falling. Another equation that we're going to end up looking at is we're going to look at this one right here. The vertical displacement is going to be equal to the initial vertical velocity multiplied by time plus 1/2 gt squared. Now, let's look up here. This ball's rolling across the table. It's not moving up and down. So if it's not moving up and down, guess what? We can go ahead and get rid of that. So really, if we're talking about horizontal motion only, y is going to be equal to 1/2 gt squared. And then the other equation that you're going to have is VYF. Final vertical velocity is going to be equal to the initial vertical velocity plus gravity times time. Guess what you did earlier? You X that out because, again, there was no up and down motion. For horizontal motion only, we can do this. If we have both horizontal and vertical, we're not going to be able to do that. One of the equations that you're going to use a lot is going to be this one right here. Y is going to be equal to 1/2 gt squared. Because really what we're going to do is we're going to solve for time. And we're going to say that time is going to be equal to 2 times the vertical height divided by gravity, and then again we're going to have to take the square root of that. Okay, let's go ahead and focus on this first problem. It says, what is the horizontal displacement? So x is going to be equal to Vxi multiplied by time. So what we're saying is x is going to be equal to 4 meters per second multiplied by time. But I don't have a time. Well, if I use all of the information from the problem, I can go ahead and come back. I can go ahead and come back to this problem right here. And by doing that, let me go ahead and bring this down just a little bit more. Okay. There we go. Okay. If I go ahead and do that, I can solve for time right here. Time is going to be equal to the square root of 2, and it says up here that the height of my table is 0.75 meters. Now, one thing I want you to think about, gravity is a negative 9.81 meters per second squared. To get my math to work out, I have to say, well, the ball's going to fall, and it's going to fall negative 0.75 meters. We're going to divide that by gravity, negative 9.81. Okay, and if I go ahead and bring my calculator up here, there we go. We're going to go ahead and take the square root of 2 multiplied by negative 0.75. We're going to divide that by gravity, negative 9.81. Close our parentheses off there. And when I do that, I find out that the time is going to be equal to 0.391 seconds. 0.391 seconds. So what I can do is I can bring that problem, or bring that right back up here. This 0.391 seconds I can go ahead and place into my equation, and I can solve for my horizontal displacement. So 4 multiplied by 0.391, there we go. I'm going to find out that it's going to land about 1.564 meters away from the table. So what we're saying is this right here. This is going to be 1.564 meters away from that table. The last part of the equation says, what vertical velocity will the ball strike the floor? So I'm going to use this equation right here. So we're going to say that VYF is going to be equal to the gravity multiplied by the time. So again, we can say VYF is going to be equal to negative 9.81 multiplied by that time 0.391. If I go ahead and go back to my calculator and I take negative 9.81 meters per second squared multiplied by 0.391, I go ahead and hit enter. What we're going to say is the final vertical velocity is going to be about negative 3.84 meters per second. So we're saying that it's as it falls, as that ball falls towards the ground, it's going to pick up speed. It's going to go from 0 vertical velocity to a negative 3.84 meters per second, and that'll be your final vertical velocity.